All right, so I'm going to be talking about how to do this synthesis. We're starting with an acyl chloride and cyclohexanone and ending up with this molecule over here. So a few things to note. We see that there's an aromatic ring on our product, so that means we're probably going to be doing an electrophilic aromatic substitution. And also we note that we have 2 carbonyls in our starting materials and none in our finished product. So let's start with the ring. We see that we've got 2 substituents on the ring and they're in a meta relationship with each other. But NH2, as we know, is an ortho-para director. So the question is, how do we get these meta? So one way we can do that, NH2 we can make by reducing NO2, which is a meta director. So if we say that, then we start with this here. So the next question is these double bonds. So we've got these 2 carbonyls in the starting materials, none in the finished product. And one way we can get rid of these and have these double bonds is by doing a Wittig reaction. So if we do that, then all of these double bonds become carbonyls. They're all ketones. So this looks great because now we know we can do a Friedel-Crafts acylation to add this group onto the ring. So if we do that, then we know we started with another acyl chloride here. So now the question is, how do we get from here to here? We've got 2 carbonyls here and 3 here, so we must have created a new one along the way. So let's see if we can break it down. We know we can add this chlorine if we have the carboxylic acid there. And we know we can make this carboxylic acid by oxidizing a primary alcohol. And this is starting to look a little more familiar because now we've got these 2 carbonyls. How do we make this primary alcohol? Well, we can do that with a double bond. So now this looks a lot like our starting materials. The question is just, how do we get this acyl chloride onto the cyclohexanone? And one way we can do that is by using an enamine. So if we add pyridine to our cyclohexanone and we use an acid catalyst, we're going to get this enamine. So then with this enamine, we can add it to our acyl chloride and get this here. The positive charge on the nitrogen. So then the question is just, how do we get rid of this nitrogen? And we can do that. We can get from here to here by using hydrolysis. So let's go in the forward direction. So I already showed how to make the enamine. You have the cyclohexanone, the pyridine, you do the acid catalyst to make the enamine, and then you do the enamine adds to the acyl chloride, and you get this. So then you want to do hydrolysis, and you can just do HCl, H2O to do hydrolysis there. You get this diketone. Then to make the alcohol, you can do hydroboration and oxidation because this is a non-Markovnikov addition. So BH3THF, NaOH, H2O2, H2O, getting a little cramped at the bottom there. Then you can oxidize this primary alcohol into a carboxylic acid, doing a Jones oxidation with the Jones reagent. Add the forward arrows. Then you can turn this OH group into a Cl by using thionyl chloride, SOCl2. Then we're going to do the electrophilic aromatic substitution, and we want to activate the ring. Because the ring isn't active, we need a Lewis acid, so we're going to add AlCl3 and the ring. So like that. And then we have these here. So then we're going to do the Wig reaction. We just need a phosphonium ion. So like this. It's going to get us here. And then finally, we reduce the NO2 to NH2 using H2 and nickel. And there you have it. That is an easy synthesis.